Hello and welcome, this is a new episode from Aero Arduino, and in this episode I'm sharing with you this project about Arduino's smart pet feeder. If you didn't hit subscribe, please subscribe to our channel to get the latest videos. First, if you want any project or want a customized project for your school or college or any private project you want to make, you can contact us and we are more than happy to help you. I'll leave the link to the project in the video description and in comments. Here we are sharing with you this pet smart feeder for people who travel a lot and people who cannot be able to feed their pets or farm animals. They can make an automatic Arduino smart pet feeder. I've designed this system using two Arduino Uno boards to communicate with each other. One human terminal. This is the terminal where you can set the timing and information about feeding times for the pet. And this other terminal is the pet terminal, used to control the feeding process for the animal and used to determine the right amount of food to be delivered to the animal. Now let's see the connection of the circuit. Here we start with the human terminal. The components are Arduino Uno board connected to 16x2 LCD, and there are 4 push buttons. Now let's see the connection between the LCD and Arduino. Here we have 4 data pins connected from the LCD to Arduino pins, and also the control pins. Enable connected to pin 11. Register select connected to pin 12. Read write connected to ground. Contrast connected to ground. And the ground of the LCD is connected to Arduino ground. The VCC of the LCD is connected to the 5 volts of Arduino. The backlight LED cathode is connected to ground through a 1 kilo ohm resistor, and the backlight LED anode is connected to the 5 volts of Arduino. The 4 data pins D7, D6, D5, D4 of the LCD are connected to pins 2, 3, 4, and 5 of Arduino respectively. Now the 4 push buttons are connected to Arduino, pins number 7, 8, 9, and 10. And the other pins of the push buttons are connected to Arduino ground, and we use the pull-up feature in Arduino ports. This was the human terminal circuit connection. Now let's see the circuit connection for the pet terminal. The components are Arduino Uno board and 2 LEDs and an HC SR04 ultrasonic sensor for determining the food quantity. And here is a potentiometer that simulates a weight sensor for the food quantity to be delivered to the pet. And here is a servo motor that controls the feeding process. Now let's see the LEDs. The green LED is connected to pin number 6. The green LED anode is connected to pin number 6 of Arduino, and the green LED cathode is connected through a 1 kilo ohm resistor to Arduino ground. The red LED anode is connected to pin number 7, and the red LED cathode is connected through a 1 kilo ohm resistor to Arduino ground. Here the ultrasonic sensor ground is connected to Arduino ground. The VCC is connected to the 5 volts of the circuit. The echo or the receive pin is connected to Arduino pin number 11. The trigger or the transmit pin is connected to Arduino number 10 pin. Here the potentiometer that simulates the weight sensor is connected to the VCC and the ground, and the wiper, the variable resistance, is connected to Arduino analog input A0. Now the servo motor ground is connected to the circuit ground. The power is connected to the 5 volts pin, and the signal is connected to pin number 9 PWM output. This was the pet terminal circuit connection. Here's another thing that we use to connect the 2 terminals using serial communication between the 2 Arduino Uno boards on pins 0 and 1. Those pins represent the serial communication on the 2 Arduinos. So here the receive pin on the pet terminal is connected to the transmit pin on the human terminal, and vice versa. The receive pin on the human terminal is connected to the transmit pin on the pet terminal, and that represents the serial communication between the 2 terminals, the human terminal and the pet terminal. This was the circuit connection. Now let's see the code. Here we choose Arduino Uno board number 2. It's the human terminal. We start by including the liquid crystal.h library, and then we define the constants as the pins for the push buttons. And then we start by defining the LCD and its pins. Then we define the seconds, minutes, hours, alarm hour and alarm minute variables. Then the last button press mils and the button press duration constant for 2 seconds. Here is the void setup function. We start by initializing the LCD to 16 by 2 LCD. Then we clear the LCD. Then we define the pin mode for the push buttons. And we define the input pull up feature. Then we initialize the serial communication and its baud rate. Here is the loop function. We start by initializing the LCD and clearing its components. And then we call the check buttons function and the clock function and then a delay. That's all the void loop function. Then we start by defining the other functions, the clock function. In this function, we make a simple clock that calculates the time, the seconds, and increment the minutes and increment the hours. And then if hours are equal 24, then we start by initializing them to 0. We clear the LCD again, and then we print the time. And here in this function, we choose the alarm at which time the feeding process is started. And then at the time the alarm is triggered, we send 1 on the serial communication between the two terminals. And if it's not triggered, we send 0. Then we start by defining the void begin print function. This function prints on the LCD. It prints the time in hours, minutes, and it prints the different messages and the alarm choice. And here we start by defining the void check buttons function. In this function, we check the button's status. And of course, we use the debounce feature. Inside this function, we have 2 other functions, check time button and check minute button, and also check alarm button and check alarm minute button. We have the adjust time function and adjust minute function, and here the adjust alarm function and the adjust alarm minute function. Now let's see the code for the PET terminal. We start by including the servo.h library, and then we define the servo motor and the variables for the ultrasonic sensor, trigger, echo, and for the potentiometer, analog input is 0, and the 2 LED pins 6 and 7. And then in the setup function, we start by initializing the serial communication and the baud rate, and then we initialize the servo motor connected to pin number 9, and then we define the pin mode for the ultrasonic sensor and for the LEDs. And here is the loop function. We check the serial communication between the two terminals, and then, as we've said before, we check the signal coming from the human terminal to the PET terminal to determine the time for the feeding process to begin according to the alarm we've set using the time. And then if the signal is 1, we start the dispense logic function. Else if the time is not yet to begin the dispense logic function, then we make the LED red high. That indicates the dispense logic function is off. Here, this get distance function that calculates the distance from the ultrasonic sensor. This function calculates and determines if the foot. This function determines if the foot. This function determines if the foot put has become empty. And this is the dispense food. And this is the dispense food function that opens the servo motor. And this is the dispense function. And this is the dispense food function that operates the servo motor to open the mechanism for food deployment. And that's the dispense logic function that contains all the sensors, the weight that comes from the potentiometer, the distance that comes from the ultrasonic sensor, the dispense food function that operates the servo motor, digital write for the two LEDs indication, that was the code. Now let's see the circuit simulation. We press start simulation. Here we see the time now is the time for feeding. And the servo motor is open and the green LED is on. We can change the time using the push buttons. Here we change the minutes. And here we change the hours of the time. Here's the buttons for the feeding time adjustment, the alarm. When we long press on it, we adjust the alarm for the feeding time. Here we change the minutes. And here we increase the hours. And here we increase the hours. Here we change the weight of the foot deployed. And here we change the distance and the quantity of the food in the food put. Now the alarm is 11:07. Now the alarm is 11:07. Now the time is 11:10 and the alarm is 11:07. We see the servo is closed and the LED and the red LED is on. Now we see the time now is 11:07 and the feeding is 11:07. So the servo motor starts to rotate and opens the dispense mechanism to deploy foot. That was the circuit. I leave the link to the code and model in the video description and in comments. And if you need any project, you can communicate with us to help you designing your project. And you can see more projects on our books on Amazon. And stay tuned for more circuits and more projects. If you have any ideas or questions, you can leave it in the comment below. And if you like this video, please click like, share, and subscribe. Thank you and goodbye.